signal produced by an analog synthesizer will be smooth and continuous, whereas a digital is a recreation. Typically, analog synthesizers will be more expensive. A modular synthesizer is made up of specialized modules that you put together using cables, whereas an all-in-one will typically have everything you need inside of one box. Monophonic synthesizers can only play one voice at a time, whereas polyphonic can play many. The oscillator is the source of the sound. Think of it like a raw piece of marble we'll sculpt into our finished tone. Basically how this works is the circuit inside of the synthesizer converts DC power into an AC signal that fluctuates according to a particular pattern. The pattern is the waveform. It's a triangle wave. This is a sawtooth wave. This is a square wave. And this is a pulse wave. So they all have their own sound and you can morph in between them. To begin shaping our sound, we'll carve out a part of the signal with a filter. The filter is arguably the most important component of the sound. This is stripping out harmonics of the signal while not affecting the pitch of the sound. Resonance is another essential aspect of filters that can give them unique character. Resonance creates a boost around the cutoff frequency and strongly amplifies that frequency. So this is us opening the filter. You can hear more harmonics, bring it down, you can only hear the lower of the frequency spectrum. You can also mess with the resonance, which just gives it a more sharp feel. You can really hear the frequency that we're cutting out. Moving a highly resonant filter around will create a wah-wah effect. Now we're going to look at modulation. Here you're basically going to want to look at LFO, mod, pitch amount, and filter amount. Think of an LFO as another oscillator just playing very slowly. So slow that we can hear the pattern going back and forth. You can see here, we're modulating the pitch using an LFO. So the pitch is going up and down and up and down. You can see this flashing light is how quickly it's going. We can go to the point where we can't even hear it going up and down anymore. It's like a single tone. We can change it to going back and forth. And this is almost like a fire alarm type sound. So this is just add a lot of interesting texture to the sound you're making. Here is the envelope generator. An envelope is generally defined by 4 parts: attack, decay, sustain, and release. Attack is how long the signal will take to reach its peak amplitude as set by the output level. Decay is how long it will take from the peak amplitude to decay to its sustain level. Sustain will set the level the signal will remain at as long as the key is pressed. Release defines the time the signal will take to return to 0 after the key is released. Here we're going to look at the step sequencer. You see that we're adding notes into the sequencer and they're flashing up in lights there. Now if we engage it and we replay that key, it'll go through that same thing that we recorded before. We can let go and it can actually do it itself. This is fun to use because you can mess around with different notes and different parameters. You can also touch on these and get rid of that note and that certain pattern to get more interesting rhythms. By using these fundamental pieces, there are a huge variety of sounds at your fingertips. Spend time exploring how running an oscillator through a filter can be affected by routing envelopes and LFOs, and you'll quickly be on your way to a great understanding of the building blocks of synthesis.